Thank you. So I'm very happy to be here because it's been a dream of mine to get package managers more involved with SBOM delivery and SBOM consumption. So for me, this is like a great opportunity to talk to all of you. I've been involved with SPDX for over 10 years, almost from the very beginning, and we're still working hard to get more adoption of SBOMs in the industry, although things are moving a lot faster now, so due to some regulatory changes. So what I wanted to talk first about is the challenges in the software supply chain. So when you think about the software supply chain, from the first developer who writes the first line of code all the way through deploying some critical software, say on a medical device, there's a long chain of software delivery that's involved. And there's some particular challenges that relate not only to security, but things like license compliance and maintainability as well. And what I'll be talking about is some of the challenges and how utilizing standard software bills of materials like SPDX can help solve some of those challenges. So first, in terms of the challenges, I'm going to pick on anybody here from Node Package Manager? The JavaScript community. I'm going to pick on you guys because you got I think the hardest problem in terms of how many dependencies you guys have. So one fact that I picked up is from GitHub itself is that the average number of direct and indirect dependencies for a JavaScript package is about 683. And if you look at the direct dependencies, it's much, much smaller than that. So being able to identify all of these is particularly challenging. The other fact here, which came from Sonatype, is there are on average 1.2 billion vulnerable components downloaded every month. And what's interesting about that is that a vast majority of those vulnerable components are fixed in later versions, yet people are still downloading the old version, even though all they have to do is update the manifest, download the more recent version, and it'll be fixed. So it's a particularly challenging problem. So when we look at the typical large-scale applications, I know a lot of us think about our own little environment that we're in terms of the package managers, the software system, the build systems. But if you're deploying a large-scale application, you typically have it broken down across many different build managers. I know I was talking to Sebastian about ORT. They deal with this every day because they're span across all these different package managers. But if you look at the front end, the back end, and then the base OS, you may have a package manager, a language package manager for the front end, a different one for the back end. And then you have a system package manager, which is delivering the base operating system that's there. And each one of them have their own little dependency challenge in terms of being able to understand what all the dependencies are. And then that creates a problem for those of us at the end of the supply chain, because each of these involve different ecosystems, different ways of representing the dependencies, different, quote, standards of how they're represented, and their own format for outputting, what's actually in the different packages. So it ends up making it very hard to determine, all of the components that are there at the top level, and hard to find the vulnerabilities that are there as well, because you have to go to different sources with different standards. And then equally challenging is how do you communicate it to your downstream, because now with the regulation changes in Europe, in the US, Japan, everybody's being required to deliver a software bill of material along with their main application. How can they do that if they don't know what's in the system that's there? I want to talk a little bit about functional safety. This is getting a lot of attention. Again, think about a medical device, but there's a lot of different areas where the safety of the software is critically important. You don't want your embedded device inside your body to go bad on you. You want to make sure that everything is very, very safe. There is a particular challenge around that area, and I'm going to come back to that because I think it actually puts even more requirements on build systems and package managers in terms of the information that you need to deliver if we really want to make these things completely safe end-to-end across the supply chain. So I'll switch a little bit, talk about software bills and materials, how they can be part of the solution. I'm kind of assuming all of you are familiar with SBOMs, but if you're not, this is I just picked up some definitions from the U.S. government. Has a CISA, Cybersecurity and Infrastructure Security Agency, is doing a lot of efforts in SBOMs, also the NTIA, and this is basically basically how they define an SBOM. I'm not going to read that. What I'm going to tell you is the way I think about it. It's like a list of ingredients. When you pick up a food container and you're concerned about your peanut allergy, it's nice to know what's in the food that's there so you can pick that out. Similarly, within software, if you're worried about security vulnerability, you have a vulnerability database. You want to be able to know what's in there so you can compare it to your vulnerability database and see if there's an issue. So that's what an SBOM is. When you drill into it, there's actually many different types of SBOMs, and it depends on where in the build cycle you are, and you build these different types of SBOMs based on what you know. Now, package managers, I think, is in the best position, I think, across all the different components of the software delivery system to know what's in the system, because you're actually packaging it up. You know what's being delivered. And so that's why I'm really happy to be here to talk to you, because I think you guys can help solve this problem. But there are other types like source SBOMs that are known to the compiler, runtime SBOMs that are known to the software that actually does the deployment. And all of those are important. So how does this relate back to this picture here? So this is basically the state that we're in today. Each of the package managers for each of these different layers is producing different standards. Makes it very hard to create a be able to analyze the vulnerabilities in the database. The idea is that we use standard SBOMs that allows us to bring all these together into a standard application SBOM that merges all the data together, and now we can very easily go to a vulnerability database that's in there. A very important part of functional safety is traceability. And so when you look at the traceability and how SBOMs relate to that, we start with the build SBOM that knows what the software that's being built. We can use a deploy SBOM to know what's actually being deployed. And then there's the runtime SBOM that actually knows what the software that's running. All of this is very important to know whether you're running safe software or not. But there's a little bit more to that. There's as we mentioned before, there's a number of different build SBOMs from the different environments and the different package managers that's building it. And then here's the piece that you may or may not be thinking about. We actually have to go all the way back to the source, because when you're dealing with functional safety, they need to be the actual requirements of functional safety is we have to trace from what's running on the hardware all the way back to the source file and even further back to the requirements on that. So keep that in mind when you're thinking about producing SBOMs. The closer you can get us to the source, the more you're helping us solve the problem of functional safety. So I'm going to hand it over to Max, who's going to talk about how we actually do this, how we actually solve this.
Yeah, and I will try to keep up with your impressive pace. And I will try to keep it in a fluid, as you did, but I fail already. But yeah, I want to talk about, but how? How do you, how does, what are we hinting towards, or what is this SBOM in detail? So yeah, there are some standards for software bill of materials. There are the two public, big, known open source or open standards are SPDX and CDX. They are, both of them are described in public, and you can read up on them. The question what to put into them also is answered by the NTIA. They published the NTIA minimum, which is name, version, some additional information, a lot of sane information that should be at least in there. Then if a SBOM is generated, you should pack at least the most identifiers you know in there. So if you come from a direction where you know that's the CPE of something, put it in the SBOM, since later it's hard to regenerate these identifiers. Same is true for the package URL, which is very well known and helpful in that regard. And as we just saw, if you can link this information down to source and pin it to source, also add that to an SBOM or to the output to have traceability and to be able to understand it after the fact. For example, for SPDX, there's a bunch of libraries on GitHub for different programming languages. Also, several tools have implemented their own support for SPDX, for example, Ord again. You can look at the schemas, which are in the spec repository on GitHub. And if you really want to dig deep, you can read the spec, which goes into detail over all the fields. And similar things exist for SCDX. And then the big grand finale, call to action. So, as Gary said, we think that package managers for system package managers and language package managers are at the best position to have the data, to persist the data. And why is that? Because usually or previously, SBOMs are often generated with imprecise and heuristical methods. They are tools that look through output files that try to parse the package JSON and try to recreate the choices that were made. Or they are trying to reproduce what was done in a different ecosystem with different parameters, with a different build configuration at a different time point. They are trying to recreate dependency resolutions, which is hard, as we all know, and no one can do it right after the fact. And matching with fingerprints and hashes is prone to false positives and errors. So these problems have issues. And the best solution is when you have the information, when you just resolved all the dependencies and when you know which patches were applied, persist that in an SBOM, and then no one needs to fall back to these methods. And the second thing is discoverability and composability. So just producing an SBOM is the first part. Someone needs to find that. It would be good if it would be placed next to the package artifact in the registry, or yeah. So and composability means that if you are building a bigger thing from composing smaller artifacts, like you are packaging multiple dependencies into a bigger artifact. If you can get the software bill of materials of these smaller things that you package, and you can compose them to a bigger software bill of material, and you can link that correctly, you can specify which patches you applied, that helps you to get this flow and the final SBOM in a better and more direct way. So that, in the end, helps to identify which vulnerabilities were actually fixed. Has the package manager applied patches which made this version safer than you think or than you might expect from just looking at the name and the version? That's the question that can be answered. And yeah, that's the second big item where we see that it could help. And that's the call to action. Yay, do more SBOMs. And I think we have time for questions. I have no idea where we are on time.
How are we doing on time? We are super good this time. All right.
Super good.
Yeah, thank you.
I already saw the first hand raised there.
Questions, then I'm going to go around and... Oh, okay, perfect.
Does this work? Oh, there we go. Yep. Thank you. So pardon me, and feel free to tell me if you don't feel like totally equipped or wanting to dig into these, but I do want to dig into like maybe a little bit of the core conceit or some of the premises of your topic, just because these are the things that at least give me pause or that I think about a lot as a maintainer. So the SBOMs make a lot of sense for discoverability, but there's kind of some underlying premises that I'm not quite entirely sure that you can get a lot of agreement or consensus on. So like let me dig into those a little bit. So like one of them is the assertion that there is lots of vulnerable software that is downloaded. I think an important thing to realize is that because something includes a CVE or other identifier does not necessarily mean that it's exploitable or that there is any real concern. And so this is the main thing I wanted to ask about, kind of what your thoughts are. So for example, lots of code is simply not reachable, not importable. And the tools that exist today, and the tools that like you're talking about here using with greater visibility into software dependency trees with SBOMs, are simply doing a version comparison or a fuzzy match that is often incredibly imprecise to try to determine whether something is vulnerable or not. So I guess my first thought or question is, how do you make that situation better? Because like the status quo that exists today is, as a maintainer, I'm told my company has some policy that there can be no vulnerabilities over a certain magnitude in the, say, the container images we ship to production. You as a maintainer should, even if it is as simple, right, as quote unquote bumping something in a manifest, you as a maintainer should warm up your entire release train, do your entire release engineering process simply to appease a corporate tool that I use that you have no exposure to or any insight into, and that most of the time, again, in my experience as a maintainer, is returning a false positive. Sure, this component is somewhere in the transitive dependency tree, but the functionality that is allegedly vulnerable is not even importable or reachable from any real code, right? And so, like, my immediate knee-jerk reaction a little bit is, are you telling me that I should be encouraging more people to come to my open source project and report false positives and say no, argue with me about warming up an entire release train to satisfy a tool that's just doing a version comparison and declaring that the software must be vulnerable?
Yeah, there is a solution to that, and that I think VEX is its name. That's a standard how to explain additional meta information about vulnerabilities, for example, in a software bill of material. And a VEX statement can be something like, there's a vulnerability, but in this scope or in this use, I'm not affected because, and that is machine readable and can automatically be resolved so that in your SBOM you can say, this has a TLS issue, I don't use TLS, I'm not affected, this vulnerability is not a problem in this SBOM. So there's a solution to that, and that also comes with SBOMs. Do you want to add something?
Yeah, that's going to be coming out in our 3.0 release, so of SPDX. We'll have a formal ability. You can do it today through external references, but it'll be even smoother on the next release of SPDX. So somebody who downloads, if you are a maintainer and this vulnerability doesn't affect me, you can put that in your SBOM. And then hopefully people downstream will see that and say, okay, I believe you. You don't need to update the packages. By the way, I'm a maintainer too. I feel your pain. I actually do feel the pain because I have the same issue that you have. And I am guilty of overhyping it on that second slide. That really is the number of downloaded vulnerabilities, but does it really affect anything? Who knows? So VEX, as Max mentioned, is a solution that will be employed. And again, it's part of the SBOM standard. So SBOMs can help you solve that as you go forward.
So I guess that is kind of my follow-on there, is actually distributing that information, because, more or less that is what I'm told is, use VEX when I ask scanner vendors. But there's not actually a way for me, unless I'm a very high-profile project. Like there have been some cases where, oh, this is a false positive in these pieces of software. Oh, hello, maintainer of a well-known open source project. Yeah, we'll work on a VEX file that says, oh, the maintainers of this project have studied the issue and believe it's not reachable. Great. However, there's a generalized discoverability problem there, right? So, and I guess this gets to my last follow-up. I should ask if anybody else intends to ask questions because I don't want to take up all the time. But in my experience, there's a degree of definiteness required there. So one, there's no method for me as a maintainer today to publish VEX in a way that scanners will pick it up.
Right.
And even a lot of the CVE streams that exist do include VEX and do have a lot of those aspects. However, they require a degree of definiteness, which we don't typically have as upstream maintainers. So for example, Debian has DSAs, but there is no centralized stream for me to make VEX discoverable to scanners that is kind of equivalent to that. And then also, my last follow-up is somewhat related, so I'll just say it now. There's also a degree of definiteness that a lot of the SBOM work seems to require that's not necessarily the easiest thing to achieve in the real world. So an example here being, say with Python packages, we have a single package namespace, and we don't have any concept of alternate namespaces. If I provide a forked version of an upstream package, there's not really a great way to communicate, oh, this is coming from my fork and not from the original upstream. Outside of certain ecosystem-specific mechanisms, like in Python, we have local version numbers, but those aren't well understood outside the Python ecosystem. Or even multiple packages competing under, or multiple versions of a package competing under the same name don't seem to be particularly well handled today. So a lot of this work seems to require kind of a degree of definiteness. This is the one source code repository for this particular package that is somewhat harder to achieve in the real world. Like, are there any solutions to that kind of issue?
I think this solution. I think the answer to that is if you download the SBOM from the same place where you just received the binary. If you get them always in pairs, that SBOM will contain the information, will be the relevant thing. So you don't need to search for the SBOM after the fact. So that's the native support of a package manager. If the package manager on pulling artifacts always pulls the corresponding SBOM and keeps them aligned, you don't have this mismatch issue that you just described. But yeah, there is a heuristical issue. If you look for an SBOM and if you just have a name and a version, it's hard to match what you're looking for. But that matches also the slide that after the fact, it's hard to reconstruct what was done. Where did it come from? You need to remember that, or you need to persist that on build time initially.
And if I could just add to that, within the SPDX spec, we have a field called external references, and we have a download location. So if you know where the package is downloaded from, that can help you disambiguate, between these different, forked versions. And then in the external identifiers, we have things like omnivores, which is the same hashing mechanism Git uses to identify the package. So if you're an open source project, that's something you can use to make sure that you uniquely, it's a hash of the hash of all the, of the files and directories. So you can be absolutely sure you're talking about the same thing. So that's another mechanism you can use.
And so maybe it's a little bit of a chicken and egg problem, is that scanners currently don't care about this today. More or less, they reason in terms of package indexes. But
sorry, maybe there are some more questions. Maybe we should give some room to.
Yep, and I'll just very briefly, the discoverability of X, once 3.0 is out, that'll be a lot easier. SBOMs will help you in the discoverability, just like they are in dependencies. So
we're a little bit lucky with the first session because we have a bit more time for questions, but I'll hand over.
Thank you for the talk. So I was curious, you brought up integration with package managers. Do you envision this integration being purely for the consumption of other tools, or do you envision package ecosystems actually replacing their current log file and pinning formats with SBOMs?
One more time. Could you just repeat that?
Sorry, yes. Yeah. Do you envision package management ecosystems replacing their existing formats with SBOMs, or do you see this as a complementary?
I think of it as complementary. I think it's kind of hard to give up your own native formats, but if you produce a native format and then you produce this, then the downstream tools, it'll just be so much easier for all of the consumers of your packages.
Thank you for the talk. My question is more from a package management tooling author perspective, which is SBOM support needs work. Who's going to do it? Where's the engineering time, investment, developer time going to come from?
Yeah. I think, so we're within the SBOM community, we're doing everything we can to make it easier for you. And if you see opportunities, let the community know. If you had this, so like the language bindings. So we have a Python library you can go use to generate SBOMs. We have a Golang library, a Java library. And we're soon to come out with a JavaScript library as well, or a TypeScript library. So we're trying to make it easy for you to do that, but there is always that last little bit of work. And I would put it it in with where you find the time to solve your security issues. I think if you put the effort into this, you think of it as, oh, I got a vulnerability, I need to put time into this. I could put that same time into SBOMs to prevent vulnerabilities in the future. So prioritize it, in that way. I wish I could make it just zero effort, but like I said, we're doing what we can.
I would like just to add something, minor thing to that. I think that solves also problems for big enterprises, so let's hope big enterprises invest. Yep.
Actually, to partially answer that, I think it's the build tools problem to help build the SBOM from the things you're using as a build tool guy. We're trying to do that internally. It's not so much a question as an observation that we've found in doing SBOMs internally. The lawyers want us to produce an SBOM that covers, I use that package at that version, because we believe our customers really only care about being called on the carpet and saying, do you have that bad Log4j in that software you buy from Google? And they go, no, we don't, sir. And they go, good, very good. And the security people want us to go down to the level of sources, like you talked about. And so there's this tension between the SBOM we use internally to really diagnose a problem and the SBOM you want to publish. Because we worry about customers who do naive scanning and say, this product has config.h in it, and there's a vulnerability in that in something, and you go, oh, no, everything has, it doesn't mean anything. So they have to be, we're sort of shooting for the lowest common denominator analysis of the SBOM from a customer's point of view. And do you have any thoughts on that tension?
Do you want me to?
No, I won't. There's a good example from the Zephyr project, which generates multiple files as an SBOM. It generates a file that describes this high-level SBOM, that how is stuff linked together, but it also generates a low-level, how does source code relate to that, which .a file was built from which .c file and stuff. So it's spread over multiple files, which are linked with identifiers, which build a bigger data set. So you can have this graph, this network of information, but you don't need to expose the full level of granularity to everyone. Was that good?
I think that's better than my answer, so we'll go with that.
Okay.
Thank you.
Okay. Let's do it the last one because we need to. And also, there's a chance to talk online.
So my question is, how am I actually supposed to trust an SBOM? Because if you say it's an external thing and a library maintainer just adds it, but if I use an open source library, I just have to trust it blindly. Also, you said the exclusion syntax, I'm not vulnerable to this. So my question is, what actually is the value add if this isn't integrated deeply into the packaging ecosystem, built in and coupled with static code analysis?
I'll take a stab at that. At the very beginning of the talk, I said SBOMs are part of the solution. It doesn't solve the trust issue, but there's a lot of effort going on within, for example, the OpenSSF organization, which is another Linux Foundation project. SigStore. There's some other projects that actually do solve that problem. So when you look at the complete solution, I would encourage you to look into OpenSSF, the different sub-projects in that, as complementary. And we do work very closely with that organization in terms of how you can trust the SBOMs and be able to verify that technically.
Yeah. That's the Open Secure Software Foundation, right?
Yep. Thank you.